All right, so today we're going to cover the notes for section 2.3, which is solving inequalities using multiplication or division. What's a really quick review and important, though, is that in the last section we learned the addition and subtraction properties of inequalities. So for example, if we start with an inequality we know is true, like 4 is greater than, let's do 14 is greater than 5. If we add or subtract the same number from both sides, like if I subtract 6 from both sides, I still get a true statement, right? It started true, 14 was bigger than 5, and then after I did subtraction, it's still true. And we realized you could do that with any number as long as we're adding and subtracting. So like if I add 100 to both sides, 108 is still bigger than 99. So I can add or subtract without changing the truth of something. But let's think about multiply or divide, and that's kind of what we're learning today. If I start with something that's true, let's say 3 is less than 9. Sometimes we see that it works. Like if I multiply both sides by 3, this turns into 9, and then this turns into 27, and this is still true. The original statement I started with in red was true, and now the purple one is true. So when I multiplied by 3, it made sense. Even if I multiply by like some sort of fraction, like if I multiply by 1/9, this would turn into 1, this would turn into 3, and then this is still true. But what we'll notice with multiplication is it's not always going to work. If I multiplied by -5, let's say, this turns into -5 and this turns into -15, but this statement is no longer true. So we need to watch out when we're multiplying or dividing, and there's two main things that we'll learn for today. The first one is the multiplication of a positive number. So on our notes, when we see this number is greater than 0, that's just a fancy thing for a positive number. So what it says, when we multiply or divide an inequality, each side of it by the same positive number, that's okay. It doesn't change the truth. However, on the back side here, when we multiply by a negative number, which is this here, so any number that's less than 0, that's another fancy way of saying it's negative. When we multiply or divide each side of an inequality by the same negative number, we need to flip the inequality symbol to make sure that it produces something that's true. And again, if we refresh that, what we did in our example is we had 4 was less than 5. And if we multiply by a negative number, like let's say -3, this turns into -12, and this turns into -15. The original symbol was facing this way, but that's not true. So in order to make it true, we need to take the original symbol and flip it around. And after we flip it around, then the resulting statement is true. So those are two types of problems that we're going to do today. And all you need to ask yourself, am I multiplying by a positive or am I multiplying by a negative? If we're multiplying by a positive, pretty much nothing happens. If we multiply by a negative, we just have to remember that we need to flip that inequality sign. Otherwise, our inequality is no longer true. So let's do a few examples here. If I wanted to get x alone in this equation, I do not want it to be divided by 4, so I'd multiply both sides by 4. So -16 and then x. Now I multiplied by a positive number, and according to what we just learned today, it is okay to multiply by a positive number. We don't need to do anything special. So that's our answer. So we'll quickly graph our solutions. So at -16, there's an open arrow, and -16 is the biggest number on our inequality, so we would shade everything that is smaller. Here, if I was trying to find the value of n, I don't want it to be multiplied by 2, so I would divide by 2. Now this brings up an important thing. It's what are we dividing by? I'm dividing by +2. And what we set up here is if I divide by a positive number, I don't have to do anything special. So n is greater than or equal to -7. So we'll graph that solution. So a closed circle at -7, and n is the biggest compared to -7, so we'd shade things that are bigger. Our last one we see, we have two more. At number 3, we see a fraction, right? 1/5 of w, or we could see this. Some people like to multiply those together and see that as w over 5. But we remember in a fraction, the denominator means divide. And I don't want w to be divided by 5, so I would multiply both sides by 5. We multiply 5 by -6.4. That will turn into -32. These 5s will cancel. And again, I multiplied by a positive number, and there's nothing special I need to do if I multiply by a positive. So we'll graph our solution, put a closed circle at -32, and -32 is the biggest because the symbol is facing that, which means my W's are going to be less than that. Our last example here, we don't want Q to be multiplied by 1.5, so we would divide by 1.5. What we can see is we are dividing by a positive number. It is okay to divide or multiply by a positive. Nothing special happens there. So here we're left with Q, and negative 18 divided by 1.5 is negative 20. And it'd be okay to use a calculator for that if you needed to. So as we graph our solution, negative 20 is there, put an open circle, and Q is the biggest thing because the inequality is facing Q, so we want the numbers bigger than negative 20. Now on the back side though, we're just practicing this whole other little thing. If we're multiplying or dividing by a negative, so you can see I put a nice little study question there. If we do that, we have to flip the inequality symbol. If we don't, the inequality isn't true, and that's what we said in our warm-up here. So let's try this one. Here is x, and I do not want it to be divided by negative 7. So here, to undo that, I'm going to multiply both sides by negative 7. So 3 times negative 7 is negative 21. The 7s here would cancel. But since I multiplied by a negative number, I need to flip the direction of that inequality symbol. It used to be opening towards the left. Now it needs to open towards the right. So we need to flip the symbol when we multiply by a negative, or divide, but this was just an example of multiply. So that's the only thing that's different here, is we need to flip the symbol. So now we can still go graph that solution. So 0, and here's negative 21, open circle, and we want all the x's that are bigger than negative 21 because the x is being eaten by the symbol. If I wanted to get m alone here, I do not want m to be multiplied by a negative 5, so to undo multiplication, we would divide by a negative 5. And as we just wrote down, if we multiply or divide by a negative, so like here I divided by negative 5, when I'm doing my work, I have to change the direction of the inequality symbol. So instead of opening towards the left, now it's going to open towards the right. So all the values that are less than or equal to 9. So a closed circle. And here the symbol is facing the 9, which means 9 is the biggest. So m's are smaller than that. So the numbers that are smaller than 9 are this way. Again, here, when we see a fraction, we should put that negative somewhere. I like putting that negative on top. So here I don't want my variable z to be divided by 10, so we're going to multiply by 10. Now it's a nice reminder, we only multiplied by a regular old positive 10. When we multiply by a positive number, we don't need to do anything special with the sign. But in our second step, I don't want z to be multiplied by a negative 1, so I'm going to divide by a negative 1. When we divide by a negative, we need to change the direction of that inequality symbol. And then we have our final answer. So we'll go graph all the z's that are less than negative 10. And again, we can see that negative 10 has the symbol facing it, which means negative 10 is the biggest. So our numbers, like are smaller than negative 10. Our last example before we do our applications is I can see the y value that I'm looking for right here is being multiplied by negative 0.4. And I don't want it to be multiplied by negative 0.4, so I would divide by negative 0.4. Now, I just divided by a negative number, so that inequality symbol needs to change directions. And negative 12 divided by negative 0.4 works out to be 30. So we'll graph our solutions. So open circle at 30. The y variable is the biggest because the inequality symbol is facing that. So we want to shade the numbers that are bigger than 30. So a nice quick little summary. When we're undoing things, when we're solving an inequality, if we multiply or divide by a positive number, it's just quote unquote normal. It's what we'd like it to be. But if we ever multiply or divide by a negative, we have to flip the inequality symbol. So we're just going to wrap up with a few application problems, which are good practice. So it says we earn $8.50 per hour at a sub shop. So we need to write and solve an inequality that represents the number of hours we need to work to earn $187 to buy a tablet computer. So let's simplify this. We're going to be writing an inequality, so we need to be comparing two things. And we're trying to buy something with money we've earned. So we have our goal that we want to buy, and then it's the money that we have or that the money that we're going to earn. When I was comparing these two things, the money that I need for my goal versus the money that I'm earning, the money that I'm earning needs to be bigger, or it could be equal to my goal. If it's not bigger, then I don't have enough money to buy my tablet. So now we'll just substitute values. So the money of our goal was $187. We'll keep our inequality symbol. Now, how do we earn money? Well, the way that we earn money is we make $8.50 every hour. Now, I can see the original question. I need to find the number of hours I would need to work. So that means I can use that as my variable. Let's let H equal the number of hours. So the money that I would earn would be $8.50 times every hour. So that was step number one. We wrote the inequality. Now we have to solve it. So I'm just going to rewrite it so I can clearly indicate my original answer for the written part. So if I wanted to get H alone, we would simply divide by $8.50. Now $8.50 is a positive number. So as we're summarizing our day, we do not need to do anything special for a positive number. And 187 divided by 850 is 22. And you'd be able to use your calculator for that. So hours is bigger than or equal to 22. So we'd have to work at least 22 hours. The maximum speed limit for a school bus is 55 miles an hour. Write and solve an inequality that represents the number of hours. So there's our command, so we can use that to define our variable. Let's let H equal the number of hours that it takes to travel 165 miles. So if we think about, we're trying to write an inequality. So again, we're going to compare two things. So we have a goal distance versus our distance that we travel. So we can substitute some things here after we think about our inequality. If we want to reach our goal, the distance that we travel needs to be bigger. And it would be okay to get exactly our goal, so we'll include that equal to. Our goal distance is 165 miles. We'll just keep our inequality symbol. Now to figure out the distance that we travel, it says it's 55 miles every hour. So I take 55 and I'd multiply it by the number of hours. So this is our answer for write the inequality. So I like to keep that a nice clear answer. Now if we need to solve it, if I wanted to get H alone, we would divide by 55. And dividing by 55, that's a positive number, so we don't need to do anything special with the sign, and this works out to be 3. So H, since it's being eaten by the inequality symbol, is bigger than 3 or equal to. So we could say at least 3 hours. A local zoo employs 36 people to take care of animals each day. At most, 24 of the employees will work full-time. Write and solve an inequality that represents the fractions of employees who work part-time, and then it says graph the solution. So what we see is it says at most 24 out of the 36 will be full-time. So what that means is that the rest is part-time. So one way that we can start to address this is for our inequality, we need to represent the fraction of employees. So fraction of employees is what we were told to represent. So P can be the fraction of employees. So if we started with 36 employees, what fraction of them would be part-time? Well, 12 or more would be. Because if this is at most, that means this is the biggest it could be. So we need at least 12 part-time. So that's why I said at least 12. Now here I'm just going to divide by 36. So P is greater than or equal to 12 over 36, and we simplify that fraction to be 1/3. And when we know that when we graph fractions, we always want to put a fraction in between two integers. So those are